We are in section 8.1 on the top of page 4. The example at the top of the page is one that we have seen already, and I rewrote the null and the alternative hypotheses on the side. And it then says the null hypothesis for the problem is not rejected. State the conclusion based upon the results of the test. So these always start off the same way. And we're going to start this off with there is. And my open math is going to do exactly the same thing. And you either say there is sufficient evidence or not sufficient evidence. And since we did not reject our null hypothesis, that means that we were okay with it. It means we would have rejected our alternative, and that was what we were testing. That means that we did not have enough evidence to support what we were testing. So there is not sufficient evidence to conclude that, and then you need to talk about what it is that your problem is dealing with, and this is that the mean price of an existing single family home has, and in our alternative we talked about it has decreased from the 2009 price of $218,600. The next example that we have says in 2010, the standard deviation SAT scores on critical reading tests for all students taking the exam was 112. This is again the same problem that we saw earlier, and I rewrote our null and our alternative hypotheses on this side. It does say the null hypothesis for the problem is not rejected. State the conclusion based upon the results of the test. So again, we are going to do exactly what we did up above. They start off exactly the same, and we're going to say there is, and again, we do not have enough evidence, so there is not sufficient evidence to conclude that the, and again, instead of saying not sufficient, you could say insufficient. But to conclude that, and we need to talk about what the problem is discussing. So to conclude that the standard deviation of SAT critical reading scores has, I'd say not has, but is different from the 2010 score of 112. There is another example right below that that you should look at on your own, and then we will look at together as a class. The next thing down below is a test statistic, and this is a value in making a decision about the null hypothesis. It's found by converting the sample statistics, such as p hat, x bar, or s, to a score such as z or t, or a new one that we're going to learn, which is called chi-squared, with the assumption that the null hypothesis is true. And again, we're assuming the null hypothesis is true, and our alternative is what we are testing. You don't need to stress so much about these formulas because we will be using a calculator. At the bottom of the page, it says the critical region or the rejection region is the area corresponding to all values of the test statistic that cause us to reject this null hypothesis. To the next page, we have different methods of doing the hypothesis test problems. The first one, which is not the main focus, is the traditional method. And this is where you would find the critical value. Again, we are using our calculator, and you're going to have a test statistic. And if it lies in those tails, which is determined by alpha, then those are the rejection regions, and we reject our null hypothesis. Again, this one's not as relevant. Our book and My Open Math is going to focus more on the p-value method. So we will glance at that a little bit and try a little bit with it, but most of it's going to be done using the p-value method. So what is a p-value? It's the probability of getting a value of the test statistic that is at least as extreme as the test statistics obtained from a sample data, assuming that the null hypothesis is true. The part in parentheses is wording it not as a textbook, but more in plain English. And so this says the probability of what you observed occurring randomly if the null is true. So with the p-value method, we have what's called rejection regions and do not reject. Rejection regions depend upon if it's a two-tailed, left-tailed, or right-tailed test. And we're going to go ahead and find the p-value on our calculator. And if the p-value is less than alpha, and alpha will be given to you guys in the problem, then that means that's in the rejection region. Then that means that we will reject our null hypothesis. We also have another method that we use, which is called the confidence interval method. And the confidence interval contains the population parameter, then we do not reject the null hypothesis. And if the confidence interval does not contain the population parameter, then we reject the null hypothesis. So, and again, we will see some problems with that, but that p-value method is the one that's going to be the one that we see the most. So the p-value method, to use a p-value to make a conclusion about a hypothesis test, we have to compare the p-value with alpha. And so if the p-value is less than or equal to alpha, then we reject our null. And if the p-value is greater than alpha, then we do not reject the null. The p-value is the probability of getting a test statistic equal to or more extreme than the test result. If the p-value is greater than the level of confidence, which is alpha, then we can say that the probability of a more extreme test statistic is larger than the level of confidence, and thus we do not reject our null hypothesis. If, on the other hand, the p-value is less than the level of confidence, we conclude that the probability of a more extreme test statistic is smaller than the level of confidence, and thus we reject H0. The next example, I'm going to go ahead and cross this off. And with this is usually a little bit of a struggle in the beginning. It takes some practice, looking back over examples, looking through your textbook until you get this whole idea down. The class also you start writing a lot more, explaining a lot more, and start seeming more like an English class than a mathematics course. So we will finish up the rest of this example, the one right below this, together.